Welcome students, welcome to the next session of structural analysis 2. So in the previous class we have started moment distribution method on a continuous beam which is having two supports fixed. Okay, firstly we will go into the previous steps and then we will generate the shear force bend moment diagram for the beam which we have given. Firstly they have given a fixed beam with fixed end A and the end is fixed at B, C, and also we are having the support B, and the first is 4 meter length and the next is 6 meter length, and it is having a UDL of 20 kilonewton per meter, and also it is having a UDL of 12 kilonewton per meter. Right? So this is the loading condition, and for this loading condition we have to generate the support moments, support reactions, moments, reactions, bending moment diagram and shear force diagram. So in the previous class we have completed calculation of the support moments. Okay, so for the calculation of support moments, what are the steps involved? We have given a brief step. First one is calculation of distribution factors, calculation of fixed end moments, and then entering into the distribution table for calculating the support moments. So the distribution factor step will come like this, considering the joint and then the corresponding members, relative stiffness, total relative stiffness, and then the distribution factors answer, and then calculation of fixed end moments. So substituting the individual member and taking them as a fixed beams with intensities and UDLs. So using WL square root 12, WL square root 12, and on the left side when it is hogging like this, hogging like this, it is sagging. Okay, hogging condition, anti-clockwise is negative, clockwise is positive, anti-clockwise is negative, clockwise is positive. So these are the answers, and then we went into the distribution table. So what we have done for the distribution table? Firstly we have indicated our joint names, and then we have indicated the distribution factors, and then we have indicated the fixed end moments. And if any simply supported end is there, we should have to give the correction. As there is no simply supported end, I can directly go into the distribution process. Otherwise, those simply supported corrections needed to be done, and then after the correction we should have to add. For that added values, we should have to develop the distribution process. So there is no simply supported ends at any other end, so we can develop for the process. And the net unbalanced force at the joint is used, and that will be distributed to the two members according to their distribution factors. And then we have given the corresponding values, and the vertical summation will give the answers. Sorry, here these two answers I have got, and these two answers will have the carryover moments. Why it is having the carryover moments? Because the other end is fixed, so that's why it will take some portion for the carryover moment, and again this portion will take as the carryover moment, as that is fixed and it will take. Otherwise, if it is a simply supported end, there is no carryover moment. Only it is a fixed end, that's why this moment is carried over to that moment, and this is also carried over to that moment. And the carryover moment will be given like this. So this value half and this value with as it is half. Now we are going for the summation, and the total vertical summation or the vertical addition has given some answers. After getting the vertical addition from the top to this value, what you can observe, some values will be there, but at the joint B, these two should be equal, or the summation should be equal to 0. So with the sign they should differ. Nearby, near to 0, the summation of MBA and MBC should come. If it is okay, then you can complete the table like this and observing the condition MBA plus MBC is equal to 0. With this, the distribution table was over. So after the distribution table was over, the last answer is the support moments answer. The last answer is the support moments answer. So support moment at A, support moment at B, support moment at C. At A, in the anti-clockwise direction, this is the answer, which is nothing but at A I am having the hogging moment of 23.87. So support moment at A is 23.87 in the hogging nature. And at B I am having two answers. On the left side, due to clockwise I have got positive. On the right side, due to anti-clockwise we have got negative. These are the answers observed. That's why on the left side due to this we have got positive, and on the right side due to this we have got negative. But it indicating at B there is hogging moment with that value. So hogging moment with the value we will indicate. And then at C point also, due to the clockwise condition, they have not given anything with a negative. So positive value I have given. As it is, that value is hogging only. So the hogging moments only we have got like this. And then going for the bending moment diagram. As the actual bending moment diagram is involving the superimposing of the free bending moment diagram and the support moment diagram. So firstly I am generating the free bending moment diagram. Taking each span as a simply supported beam. Firstly we should have to generate the bending moment diagram. So firstly the simply supported beams we have generated, and those simply supported beams only will give the free BMDs. Right? So this is the answers we are having, and for this simply supported beam having UDL over N, we should have to generate the free bending moment diagram, which is going with a parabolic line with an maximum bending moment of WL square by 8. Okay, so that parabolic curve with each WL square by 8 we will calculate. So 20 into 4 square by 8, one picture, and 12 into 6 square by 8 as one picture. So using these two answers, we generate individual free bending moment diagrams. Okay, those free bending moment diagrams and previously generated all the hogging moment support moments, we will generate the bending moment diagram. So the actual bending moment diagram, which may appear like this for the structure. So firstly, when you observe that, what you can see, and in the top, support moment at A, support moment at B, and support moment at C will come. So at A is 23.87 hogging, at B is 32.27 hogging, at C that is 37.87 hogging, which we have given as the support moments 23.87, 32.27 and 37.87 as the hogging moments, and those answers only will be useful for the support moment diagram. In the previous problem, there is no fixed end, that's why A and C are 0, but here A is fixed, C is fixed, B is simply supported at the center. So every support is having its own support moment. Okay, so support moments we are connecting with a straight line, and then individual free BMDs we have generated. So connecting those individual free BMDs we will develop, and using the height and observing this height, you can calculate the this measurement from this trapezium. You can evaluate, and for this parabola you know the height. So for the parabola you know the height, and from this you can evaluate this height. So using these two answers, the leftover measurement is 11.93. Similarly here also 32.27 to 37.87. Here you can generate the measurement at the center of the particular span, and in that beam what is the maximum moment that you can evaluate. Using those two answers, this leftover measurement will become over like this, and considering the support moment line above the line that is positive, below the line that is negative. So considering the support moment line, whatever is the curve above the portion that is positive, below the support moment line whatever is the curve area is that is negative only. Okay, so this is the way for indicating the actual bending moment diagram. Okay, in the next step I am going for the calculation of the actual support reactions. So what are the actual support reactions? How we are calculating? Every time repeatedly we are having the same well known step for evaluating the actual support reactions. So there we can observe at the support point, the bending moment at the support is equal to original support moment. Okay, bending moment at the support is equal to the support moment. So using that condition, I am evaluating VA and VC, and then we will calculate VB. Like the same conditions we are going for the next. So we are going for the next calculation, that is actual support reaction calculation. So firstly I am considering a section at a distance x in the first span, again measured from A. Okay, so for this span, this is the condition. Being it bending moment diagram. Okay, this is bending moment. So what are the forces or the moments on the left side? everything needed to be involved. Okay. On the left side, here I can observe VA is there. On the left side, I can observe some UDL is there. Here VB is there. Here VC is there. Not only these vertical forces, but also at A, there is a hogging moment. So, the hogging moment answer is there. What is the value? 23.87. And also, at C, there is a hogging moment. What is the value? 37.87. And also, at B, I am observing hogging moment as the final hogging moment answer also you can indicate, that is 32.27. So, these are the moments you are observing. Okay. Firstly, I am taking a section and a distance. And for writing bending moment, please don't forget the support moment. That is also needed. Okay. So, the first thing is bending moment at B in the span AB at a distance, bending moment in the span AB at a distance x from A. Okay. Now, bending moment at B is equal to, which is equal to VA up to this section, VA into 4, and we are having an hogging type moment. See here, when you write like this, from the section it is causing negative moment. That's why minus 23.87. And also I am having UDL 20 of x length. So, minus 20 into x by 2. So, I am directly writing the bending moment at B. If it is x, the corresponding x I should have to do. If I am writing at B, I can directly consider up to that B point. Okay, 20 into 4 into 2. So, 20 into 4 into 4 by 2. If it is at any section, the corresponding equation will come. Here I am directly calculating at B, right? So, no need of giving the x equation. Directly at B from the left side. Again, directly at B from the right side also you can generate. Now, the actual supporting moment at B is, what is the actual support moment at B? 32.27 hogging nature moment. So that's why minus 32.27 in the sagging nature, because myself sagging is positive, hogging is negative. So this hogging moment I have indicated as negative, and here also sagging is only considered positive, hoggings are considered negative. That's why VA into 4 minus 23.87 minus 20 into 4 into 2, and which is equal to minus 32.27. And finally, we have developed the answer as VA is equal to 37.9 kilonewtons. Okay. So, in this way, we have completed the calculation of VA. Similarly, for VC also we go with the same step. Okay. VA, VB, VC, support moments 23.87. 32.27. 37.87. Right? So, this is the support moment indication. Okay. So, this part was over, and what I am doing now? I am calculating bending moment at B only, but from right side direction. Okay. So, from the right side direction, bending moment at B is equal to, see here, again I am observing at this B position, but from C side. What are the forces involved? VC into 6 meters. VC into 6 meters. And also I am having a moment 37.87. Now, for this section line, and the corresponding moment is like this. So, what it is causing? It is causing hogging type moment. That's why negative. So, minus 37.87. And also I am having a UDL of 12 intensity or 6 meter. So, 12 into 6 into 3. So, support reaction into force, moment Moment will not have perpendicular distance. Moment itself is the perpendicular distance multiplication. It's the moment answer, right? So don't multiply with anything. That is as it is. Force into distance. It is the moment as it is. Intensity, length into perpendicular distance. Okay. In this way, we have got bending moment at B from the right side. But actually, we know bending moment at B is 32.27 hogging in nature. That's why minus 32.27. And equating these two, we have got the answer as BC is equal to 36.93. So, this is the calculation for the support reaction at C. Now, finally, when you give the answer for the VB. For VB, what we have done? Again, we have used vertical equilibrium equation. From vertical equilibrium equation, what it is that VA plus VB plus VC is equal to 20 into 4 plus 12 into 6. Intensity into length into intensity into length. So, the two UDLs and corresponding lengths. So, this is the summation. But I know VA and VC. So, the unknown is VB. So, that VB I am keeping here and taking VA and VC that way. So, 80, 72 minus, how much we have got for VC? 36.93. VC is 36.93 and VA is 37.9. So, with this, we have got VB, vertical reaction at B as 77.17 kilonewtons. Okay, so this is 77.17 kilonewtons is indicated, and finally, the overall support reactions will be written like this. Just now only we have given those answers, right? So VA is 37.9 kilonewtons, VB is 77.17 kilonewtons, VC is 36.93 kilonewtons. Everything is in the upside direction only, nothing we have got negative. Okay, so everything are these answers, these are the support reactions. After getting these support reactions, our next motto is calculation of the or generation of the shear force diagram. Okay, first now we are going to the actual shear force diagram generation. So now the actual shear force diagram. How we will do that? Again, we will consider the spans. Where the load is varying, we will take another span. Firstly, I am taking the first span, which is in between A and B, and it is at a distance x from B. If you want, you can indicate the moments also, but shear force will not involve moment answers. Even though the moment is there, those answers were still there. Okay? I am not writing for to not waste my time, because I am not involving the moments. Only the summation of vertically upward forces or downward forces for the left section or the right section. Okay? So that answer only I should have to write. Now, bending moments, shearing force at a section x at a distance. So, shear force in the span AB at a distance x from A. The left side forces summation is left side upward plus VA so left side upward VA and minus 20x. So VA minus 20x. That is the equation up to this point. Any other vertical load is there? Only moment is there. I don't want the moments. Only vertical forces, intensity into length, the corresponding loads. That's it. Okay. So VA, how much VA we have got? Support reaction VA is 37.9. 37.9 minus 20 into 0. That is 37.9 kilonewtons only. And then 37.9 minus 20 into 4 meters. So that is minus 42.1 kilonewton. In this way, for the left and right points of the span AB, we have got the shearing force at the corresponding points. And then the next span, now we are considering the next span, that is BC. Consider a section at a distance x from, considering span at a distance x from A, but the span is located in BC. Okay. Now summation of all the left hand side forces at the corresponding section. Fx is equal to plus VA and then plus VB and minus 20 into 4 meter complete length was there on the left, and also minus 12 into x minus 4. Okay, so how much intensity is there? How much length is there? Without going blindly, you should have to observe what are the things there. On the left side, intensity and length is there. Some intensity and length is there. So what is the corresponding length? As it is 4 and it is x, the remaining length is x minus 4. And substituting that VA answer and VB answer, 37.9, 77.17. So this is the Fx equation we have got. (37.9) plus 77.17 minus 20 into 4 minus 12 into x minus 4. Now substituting that, x is equal to 4, the last term will remove. 37.9 plus 77.17 minus 80. So this answer we have got as 35.07 kilonewtons. Okay, so that is the shear force at B, just to the right of B. Okay, next thing at C point, 37.9 plus 77.17 minus 80 minus 12 into 10 minus 4. So this is the multiplication, and we have got the shearing force at C is equal to minus 36.93, and when you observe, this is the support reaction at C, and also support reaction at A also we have got. See here, 36.93 and 37.9, 77.17. 37.9 shear force at A, 37.9. Now, involving all these things, I should have to develop the shear force diagram. Okay, so 37.9 and minus 42.1. Again, and connecting these two, there is a straight line with x as a single degree, and connection line is like this. Only for this span. Again, for the next span, from the baseline the picture will start. Okay, like this it will continue. And the next span we have got from B positive 35.07 and the negative of 36.93. And connecting these two, again there is a single degree straight line connectivity. So simply connecting with a straight line. Now adding at a time we will generate, but for the place purpose I have done like this. Okay, when you see this, you can observe this structure which is appearing like this, and when you see the whole structure, it is appearing so 37.9, 42.1, 35.7 and minus 39.3. So above the baseline will indicate with the positives, below the baseline will indicate the negatives. Okay. So when you see the original shearing force diagram for the given continuous beam, but what we have done here, we have done the support moment calculation using moment distribution table. Later we came into bending moment diagram generation like we already know. We came for the support reaction calculation we already done, and for the shear force diagram generation for whatever the span, whatever the loading which you can develop. Okay. When you see the whole structure at a time, you can observe the whole shape. This is the fixed beam with VA, VB and VC. Being a fixed beam, you can indicate support moments also, and the corresponding actual bending moment diagram is the merging of free beam and the support moment diagrams, and with the same continuation we have observed the points with a shearing forces at each point. In this way, the actual loading figure is generated for bending moment diagram and the shear force diagram, and individual calculation of support moments and support reactions also over. Okay. So finally, what you have observed from the loading condition, whatever is the loading way, the main concentration is on distribution factors. These distribution factors will come according to the farther ends supporting condition. So if that is hinged, we will write I by L. If it is fixed, we will write I by L. If it is hinged, we will write 3/4 of I by L for the relative stiffness. And this distribution factor is equal to relative stiffness of member by total relative stiffness at joint. At the joint means at B towards A, B towards C we have written, right? So the total relative stiffness at the joint BA plus BC. But it is individual members. So relative stiffness by total. Relative stiffness by total. The corresponding distribution factors will come. Those distribution factors, when we are writing the relative stiffness, these are the conditions. It is for the fixed ends. This is for the farther end is being hinged. Okay. So being the intermediate support, that will be indicated as a simple support only. But that is not our motto. What is the condition of the farther end? I am observing at this joint, that is simply a supported. Just it was placed like this. But what is the condition of the farther end? Based on the condition only it will come. Okay. And from the distribution factors and calculating the fixed moments for the given loadings for the spans, and we will generate the moment distribution table, and finally we will observe the moments, and with the practice only you can develop the table with the value which you are carry overing or where we are adding, and then what is the unbalancing, again distributing, again fixed end is there, we should have to carry over. If it is a simply supported, no carry over to the last. Okay. So in this way the moment distribution table generation is very important. Please practice for the numerical problems, the even point loads and UDL combinations also. Just simply I have taken UDL, maybe point loads, eccentric point loads also may be there. Only the formula changes. Starting fixed moment formula is there, right? That only changes. The remaining things as it is. Free beam diagram shape changes. Okay. Thank you for today's session. We will meet in the next session with some numericals. Thank you.